Hello, this video is going to go back and review some of the things with measurement. There's a few of you still having some issues of how to properly read these rulers. This is not exactly the same ruler that we use in class, but it has some of the same characteristics. The one thing that I want to talk about in particular is this notation, because it tends to be very confusing for students. Because this does say millimeters, and so somehow I think students seem to think that the distance from here to here is 1 millimeter. This is actually should be labeled centimeters, because actually each of these big number graduations or lines that are on the ruler do measure by centimeters. So that if we have a line that goes from here to here, it is exactly 1 centimeter. From here to here is exactly 5 centimeters, and so forth. What we're going to practice today is how to use these little lines to measure exactly where measurements might look like. Let me adjust this a little bit because I'm having a hard time seeing the very ends of these after the first centimeter or so. Well, we'll try it here and we'll kind of see how it works. Evidently this ruler has got the lines that are worn off a little bit, but I think we can tell close enough where they go, at least as long, if our lines are not too long. All right. The way we find out the graduation or the scale for these is we do look at the numbers, right? And we see what is the distance from one number to the next. And for this one, it is exactly 1, as I said, centimeter. And then for the little lines, we look and see how many spaces there are between the 0 and the 1. And if we were to count, we would find out there's 10 spaces. So that means each of these graduations is, as we subtract the numbers, the difference between 0 and 1 is 1, and divided by the number of spaces, which is 10, which is a decimal, is 0.1. So each of these little lines counts by 0.1, so 0.1, 0.2, 0.3, so on and so forth. And the thing that always works with every measuring instrument is if we can measure to the nearest 0.1, and we can because that's what the scale is, we always need to estimate one more decimal to the right. When one more decimal place to the right from the tenths is the hundredths. Every single number that is ever written down with any of these rulers has to have a number in the hundredths place. The tenths place we know, right? The units place we know, I mean the 2, the 3, the 5, the 20, whatever the number is before the decimal, we would know off the ruler. We can also measure the tenths place, but then you have to estimate this hundredths place. So I just drawn a few lines at random, so let's practice doing that, and we'll see what is the best number for the lengths of these lines. All right, so we try to put the 0, the center of the 0, right on the end of that line, and we see where the other end of it ends. All right, now I can actually cheat a little bit with this camera and zoom in, right? Your eyesight may be better than mine, but so you may not have to zoom in quite like this. Let's see if I can focus it a little bit also. Okay, looks like that's as good as we're going to get. So zoom back out, it might look like this ends right at the end of this first line, which would be 3.1. Right, so if you think that that is that, and actually that last number is estimated, right? So if you thought that this measurement was, let me zoom back out again, 3.1, the way you would write that would be 3.10, because if you have to have something out in this hundredths place, as we just said, if you could measure to the nearest tenth, you have to estimate. When I zoomed in, I found out it wasn't quite there. So zooming in, I might say it's 3.08, 3.09, something like that. In reality, for the math that we're going to do, both of those numbers would probably not give too much of a difference in terms of some sort of final answer, right? But either one of those would be correct for this line. Okay, let me go to my next line. And I'm just going to show you the far right part of this line. If I can get it on the camera here. Okay, my next line is right there. Okay, I'm going to line up the right part where it should, or the left end where it should be. So all we need to look is this right end, and where does it end? Well, this one looks a little bit more obvious maybe. There's 5, 5.1, 5.2, 5.3, 5.4, and then now it's halfway in between. So we absolutely know the 5.4, and then we'll estimate the next place to be a 5, right? That is in the hundredths place, and it should be. So it would be 5.45. I forgot to do this on the first one. We always want to put our labels on there. So it's centimeters. So the first one, we should go back and say it's either 3.09 centimeters or 3.10 centimeters, right? Both of these have 3 significant figures. Right? This 0 is significant because it's between a 3 and a 9. This one, it's kind of hard to tell zeros at the end technically, and this is just really kind of far out for this number. But this one should be written 3.10 times 10 to the 0 power. And that's kind of a cumbersome way of writing it, but we really should, so that we know that all three of these numbers really are significant, right? That 0 is one that I measured or estimated. I know that that should be 0, but since it's on the end, it gets kind of weird. Let's do one more line. Actually, I've got two more to do, so let's try this one next. Each get a little bit longer here. All right, how about this one? Lining up the left end. Okay, that's where the right end ends. All right, it's got zoomed in a little bit. So it'd be 7.1, 2, 3, 4, 5, 6. Yeah, what do you think? 7.67 maybe? Works for me. Centimeters, right? I'm going to focus just a little bit. Let's try one more. Okay, this one, because it doesn't make you a little seasick. It's kind of a see-through ruler, so I'm actually going to cheat and put it this way so we can see the line a little better. All right, so we have 10 here, 10.5, 10.6, 10.7, 10.73 maybe. That sounds good to me. And I have to actually zoom back out a little so we can see that. Right, and that's how we measure accurately with one of these rulers. As I've said it several times, you have to have a number in the hundreds place, because realistically that's how far we can measure. Now if I kind of cheated this over and said, well, the line actually ended there, right, then you should be saying 10.70. You can't just leave this last digit off. Now, if it ends exactly in the middle of a line, it'd be 10.70. Okay. Graduated cylinders work the same way. Anything that has any sort of scale works exactly the same way as this. You just have to be able to count and find out what the scale is. Right? You'd have to know which number you can know and measure, and then we always add one more decimal place to the right. This number, by the way, would have 4 sig figs, because the 1, the 7, and 3 are definitely measured, and the 0 is between the 1 and the 7. Thanks for watching.